Algebra lesson 6-6. Given a bunch of numbers, it's important that we're able to take those numbers and somehow put them into a graphical display to help us maybe work with those numbers. In addition, if we're looking at data itself, it's important not to only look at one form of measure of central tendency. Now, I say that because most people gravitate towards mean or average, and that may not always be the best choice. For example, if everybody in the room worked for my company and I paid them $1 a day, then the average salary for all of those workers would be $1. You'd add them all up together, divide by the number of workers, and that would give you the average salary. But if I were making $1 million a day and I put myself in the group, my value of $1 million a day would blow the amount total way up into the air, and then when we divided by everybody, it would seem as if we were all making $30,000 a day. I wouldn't be lying if I said the average salary were $30,000 a day, but it's not quite what the most average person in the room would be making. So you have to be really careful. There might be another form, maybe median or mode, that might be a better option to choose for finding the measure of central tendency. One of the things we can use to demonstrate or display data is we can make what's called a stem and leaf plot. So it's an arrangement of digits, and it takes the data and kind of puts it into an order that we can kind of look at and sort of analyze. The stem is the greatest common place value, or at least the most common. So you look at all the values and you look at the numbers themselves and you try to decide, what's the greatest place value that I could use here? That would represent the stem. The leaves is all the leftovers. So another kind of funny way to remember it is, the stem is the greatest place value. This is all the leftovers, all right? All the leaves, the leftovers. Whatever's left over, that's what you're going to use there. And as mentioned before, the measure of central tendency is used to represent a most typical number in a data set. I mentioned if everybody worked for me at $1 a day, if somebody randomly come in the room, close their eyes and pick somebody, most likely they're going to pick somebody who is making $1. Right? But when you put my value in there, it makes it seem as if everybody's making quite a bit more, which isn't necessarily true. So let's actually make a stem and leaf plot. Here's some data. These could represent heights of a building, right, or different buildings. So we would be going through and we want to look at those. Stem and leaf plot's going to look like this. S for stem, L for leaf. I'm looking at all these values and I notice that they all are having something in the hundreds. 400, 390, 510. Seems like hundreds is the most common place value. So I'm going to make what's called a key. The key tells me how to interpret this. So my key is for, let's say, 400. If I saw 4 with a /00, I know that that means 400. That slash, by the way, is this line right here. Now, I don't have anything in the 100s or the 200s, but I do have stuff in the 300s. And I go all the way up to 900. So I'm just going to go ahead and use those values. 3, 4, 5, 6, 7, 8, and 9. These all represent hundreds. That's 300, 400, 500. Then I write all the leftovers, right? The leaves. So 400 is a 0, 0. So I put 0, 0. That's 400. Cross them off because I don't want to mess up. 390, okay? 390 is right here. So that crosses out. Again, 300 and then the 90. 510. 510. 640. 560. So I just put a comma and then a 60. Because I have 510 and 560. I have two values in the 500s. Okay, now I have 320. And because I have the smartboard, I can move the 90 over, and I'm going to stick the 20 in here, because I like it to be a numerical order. 710, 810, 900, and 490. And I have all the data represented on the stem and leaf plot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. From that, I can go ahead and I can find the mean. If I add up all these numbers together, that gives me 790, 400, let's see, 790, 800, 1300, 1940, 25, 28, 20, 28, 30, 35, 30, 40, 43, 40, 52, 40, and 57, 30. So the total of all those numbers is 5,730. And there are 10 numbers, so I will take that value, 5730, and I will divide by 10 to get 573. 573 would be like right here, be a value right there. Does that seem like a fairly decent measure of central tendency? Well, there's 10 total numbers. There's 1, 2, 3, 4 numbers that are larger than 573, and there's 1, 2, 3, 4, 5, 6 numbers that are smaller. So it's not too far from the middle amounts of the values, so it's not terrible, but maybe there's something better. Let's look at the median. The median, I have to put everything in numerical order. I've already done that. My stem and leaf plot is in numerical order. Because there are 10 values, there's going to be an even number. I got to find the average of the two middle numbers. So 1, 2, 3, 4, 5, and there's the other one. So I need to take 510 plus 560. I got to add those together. 510, 560 is 1,070. And I need to divide by 2. Because that is how I find the average of the two middle values. So I end up with 535. And 535 would be like right in here. Now you'll notice there's 1, 2, 3, 4, 5 numbers. 1, 2, 3, 4, 5 numbers. There's 5 numbers smaller, 5 numbers bigger. Maybe that's a better measure of central tendency, or what tends to be in the middle. When it comes to the mode, this is tricky. Some people will look up there and go, oh, it's 10, because there's a 10, there's a 10, and there's a 10. But you got to remember, those aren't 10s. That's 510, 710, 810. So they're not actually the same number. Just like 00 and 00 are not the same number. That's 400 and 900. There are no numbers that repeat up here. So be very careful, because some people come to this mode and they go, this, because they didn't have any number that repeats. If you write down 0, you're saying that 0 repeats the most often. So really it'd be best to say no mode. Or at least none. Alright? So the key tells me the 4/0 is 400, 400, 490. That's how I can interpret the graph itself, the stem and leaf plot. And I can still find mean, median, and mode from the data itself. So it's just another way of forming the data to kind of get an idea where do some of them group, where most of them does it stretch out as it gets bigger. You can still kind of get a display of the data itself.